Hello everyone, it's Miss Mayorga. This is the video for lesson 21, complex sprite movement. For this lesson, we're going to look at the essential question, how can previous blocks be combined in new patterns to make interesting movements? And the learning objective is use sprite velocity with the counter pattern to create different types of movement. So if you remember, I can talk. If you remember, a while back, we looked at how to make sprites move using the counter pattern right here. We used the X position and the Y position to make them move up and down, and then we also had the rotation block. But as you can see, this is the pattern, right? Sprite.y gets sprite.y minus something or plus something, depending on which direction we want to move. Then we learned how to move our sprite smoothly with a different block, which is the velocity block. And that is right here, right? We learned about velocity X and velocity Y. Today we're going to put that together. We are going to use the counter pattern block with the velocity blocks. All right, so let's go back down. In today's lesson, in today's video, I'm going to go over bubbles 1 through 7 for my class. You are supposed to complete both activities in bubble 6. Bubble 8 is an optional challenge for my class, and I will not be grading any bubble for this lesson. But again, like always, what you learn in this lesson will be assessed in future lessons. Here's a little sneak peek preview into what you should be able to do, something you can do after this lesson. And the code for this is right here on the side. All right, so now my little monster looks like it's jumping. Let's get started. Complex sprite movement. I'm going to go ahead and jump straight to bubble 2 here. Velocity and the counter pattern. Using the counter pattern, if you're new to the videos and you don't know who I am, I sit on a yoga ball. So if I'm ever bouncing up and down like this, it's because I'm sitting on a yoga ball. It's very comfortable. It's a lot more comfortable than a chair. Anywho, coming back to the lesson. Using the counter pattern with a sprite's X and Y property makes a sprite move smoothly across the screen. In this program, the counter pattern is being used with the sprite velocity X property instead. Predict, what do you think will happen when the code is run? Why? Once you're ready, you can run the code to find out. All right, go ahead and pause the video. Take a look at the code here, pause the video, type out your prediction, and then come back. Okay, hopefully you made your prediction, and let's see what happens. Here's our sprite. I'm going to play it again. Now it might be a little bit hard to see, but you should notice that the sprite starts off slow and then it goes faster and faster as it goes to the right. And let's take a look at the code. The code says sprite1.velocityx gets sprite1.velocityx plus 0.1. So each time the speed is increasing by 0.1, a tenth. All right, so kind of thinking about turning when you turn the volume up on a device, right? It starts off soft, and then it goes louder and louder and louder and louder, right? So that's what's happening with the speed. It's going slow, and then it goes faster and faster and faster as it's moving to the right because of the counter pattern. All right, that's what the counter pattern is doing. Go ahead and click finish. Continue on to bubble 3. Now we're going to practice using the counter pattern. Velocity and the counter pattern. This program already makes a car move across the screen, but it's going very slowly. By using the sprite velocity X property with the counter pattern, you can change the sprite's speed during the program. Do this, use a counter pattern with the sprite's velocity X property to make the car speed up. Okay, so we're going to use velocity X, just like in the previous bubble. Velocity X, I'm going to put it underneath line 8. Don't forget to change the name of your sprite. This is car. And we want to increase, to speed up our velocity, right? Our velocity starts at 0.2. To increase it, should we use the addition or subtraction operator? We should use the addition operator. So go ahead and drop that addition operator, velocity X, right? This structure should be familiar. We've used it before. It's the same pattern. It's now just combining different things to make new movements. And you can decide how fast you want your car to speed up. I'm going to go ahead and start with 0.2 just to see. There it goes, there it goes. All right, I think I want to go a little bit faster. Maybe try 0.5. Bam, right? Notice that the higher your number, the faster it's going to speed up. So if you get too high, it's just going to zoom by. That like 25, you barely see it. So I like to keep it at about 0.5. But it's up to you. There we go. Finish. Continue. All right, falling rock, bubble 4. The rock should speed up as it falls down the screen. So now we're switching directions, we're going downwards. Do this. Use the counter pattern with the sprite's y velocity to make the rock speed up as it falls. So we're using the sprite's y velocity. So let's go ahead and do that. Sprite velocity y. Don't forget to change the name. Rock. Now the question becomes, do we add or do we subtract? Remember, in order to go down, we need a positive velocity, right? Going downwards is positive velocity. I know it's a little flipped because of like in math class, going up is positive, going down to negative. In the game lab grid, it's going to be switched around, okay? Going downwards is positive. So we want to keep the velocity positive. Right now, the velocity is 0.5. If you add or if you subtract, which one of those keeps the velocity positive? Adding, right? Adding will increase the velocity, make it more positive. So let's go ahead and grab the positive operator, the addition operator. Another velocity y block. Don't forget to change the name. And then go ahead and select how much you want to add each time. I'm going to go ahead and start with 0.25. Let's see how that looks. Whee! I'm happy with that. If you want to use a different value, go for it. Right? But it's the same structure, right? Velocity y gets velocity y plus or minus something. In this case, we did plus. You can always stop the video. I know I'm like not necessarily giving you time to code it yourself, but it's because you can pause the video at any point, code it yourself, then come back to the video. So slowing things down. The car is going to run into the water. You'll need to use a counter pattern to slow it down. It's really not that dramatic. Do this. Use the sprite velocity x block with the counter pattern to slow the car down by 0.25. To slow the car down. Is that plus or is that minus? By 0.25 as it moves across the screen. Discuss with your partner, the class, with me, yourself. What do you think will happen when the car finally stops? So let's actually see what happens. Okay. Velocity x block. This is for the car. And we need to slow the car down. Right now the speed is at 10 and it wants us to slow the car down by 0.25. So do we add or subtract? We subtract. All right, subtracting will decrease the speed. Car velocity x. And they told us what value to use, 0.25. I'm going to go ahead and play, reset and run the program. And I want you to notice what happens. I want you to take a note. Pay attention. What is happening? Here's the car. Slows down, stops, but then it goes backwards. Pause the video. Think about why this is happening. Pause the video. Think about it. Okay, did you come up with an answer? So let's see what's going on. Remember, in the code, we're telling the computer, hey, decrease the velocity, the x velocity by 0.25. Every time the loop is run, decrease the velocity 0.25. So if we take a look, the speed starts at 10. So we're subtracting. I'm going to show you the number line. We're subtracting, right? 0.25. We're subtracting. Eventually, the speed hits 0, right? But then when we get to 0, we keep subtracting 0.25. So it goes from 10 to 0, but then it goes into the negative world, right? Negatives. Because that becomes negative 0.25, negative 0.5, negative 0.75, and so on, right? It's just going to keep going into the negative. When the velocity becomes negative, the vehicle goes to the left, right? Remember, a negative velocity means a left direction. Positive velocity means right. So at first, it's positive, but it's slowing down. Positive, slowing down, 0, negative, speeding up, right? That's why it's going backwards at the end. Now we can actually fix this with a quick if statement. I'm going to go ahead and drag this into my code right here. My face is in the way, don't worry, we'll move that. And what if statement, what condition should we check for? Go ahead and think about it for a second. What condition should we check? Okay, you might have come up with a different one. The one that I came up with was if this velocity is greater than 0. So as long as the velocity is greater than 0, keep subtracting. That way, once the velocity hits 0, then it'll stop subtracting. So I'm going to use the greater than symbol, velocity x greater than 0. And then move my block that I had made before inside my if statement. So what this is saying is if the velocity of the car is greater than 0, positive, keep subtracting, keep subtracting, keep subtracting. Once it hits 0, this will no longer be true. The condition will no longer be true. So the computer will stop doing what's inside the if statement. And it stops. All right. Let me go ahead and click finish. Continuing on. And I'm actually going to pause the video here so that I could do the last few bubbles in part 2 of this video. All right. So we just covered 2, 3, 4, 5, and I'll pick up on bubble 6 in the next video. All right. See you in part 2.